last homework help video, 30 and 31. So 30, this one isn't particularly tough, but it can get really messy. So if you're not good about keeping your work, sort of organized, neat handwriting, neater than mine, this can become a mess. And then this one's got a trick to it that's not particularly tough, but it really stretches how you're going to use the Pythagorean identities. Okay. Over here, I've got 4 different trig ratios, so let's get them all into sine and cosine to start with. So this will be 1 plus sine over cosine, we're changing tangent, over sine plus cosine, and then this side will make 1 over cosine, so it gives me a little something to shoot for. Okay, this top one, I'm going to try to make it into one fraction on top so I can do keep change flip. So I'm going to multiply that 1 by cosine over cosine. Haven't changed the value of anything, totally fine. It's the same as multiplying by 1. So now we've got cosine plus sine all over cosine for the top fraction. And then the bottom is going to be sine plus cosine. And if we want to use keep change flip and really make it nice and neat, we can make it sine plus cosine over 1. So now I've got fraction over fraction. It just sort of makes it nicer looking for the next step, which is keep change flip. So we're going to keep the top. We're going to change it to multiplying, and then we're going to flip the bottom. Now we're going to do some canceling. Cosine plus sine and sine plus cosine are the same thing. It doesn't matter which order you do them in, right? 1 plus 2 and 2 plus 1 are the same thing. So I can cancel those, and then look at that. 1 over cosine. Boom, done. All right, this one's a little trickier. I like to start this one out first by squaring and foiling out the sine squared plus cosine squared now, or the sine plus cosine. This is not sine squared plus cosine squared, right? This is the same as sine plus cosine times a second sine plus cosine. So you're going to FOIL this out to start with. That's going to make this sine squared plus 2 sine cosine plus cosine squared, right? So if you just do sine squared plus cosine squared, just try to distribute the exponent, which isn't allowed, you're going to miss this middle term, and it's not going to work out very well. All right, this one. One thing I notice about this is I've got this 2 over here with sine and cosine. I've got cosecant and secant together, which their reciprocals are sine and cosine, so they're kind of related, so that's kind of good. And then I've got these 2 terms here. So one strategy with this is to actually take and split this fraction apart. So a lot of times you're combining. More often you're combining fractions. But here I'm going to split them apart. I'm going to make this 2 over cosecant secant plus cosecant secant over cosecant secant. So that cancels out, and it's just 1. And here, if I convert these to sine and cosine, they're going to flip to the top. Instead of cosecant secant, it's going to be sine cosine. So this side is going to be 2 sine cosine, and over here, it's just 1. Now, these things are getting to be eerily similar. If I reorganize this side a little bit, 2 sine cosine, that looks good, that matches. And then the sine squared and the cosine squared, I'll put those last. Well, sine squared, the Santa Claus one, sine squared plus cosine squared is equal to 1. So what I can do is I can either change this 1 to sine squared plus cosine squared, or I can change this sine squared plus cosine squared to 1 using the Pythagorean identity. I guess it would be less work to write the 1 I'll do this side, change sine squared plus cosine